Welcome to DfRSoft's instructional video on accelerated test planning. You're going to, a lot of times when you do a complicated test, you're going to spend a lot of time and money on with sample sizes and test time, and you want to know what that statistically proves. And DfRSoft makes that easy, and there's a number of options here. And you scroll down to your test plan right here. Another option will be your qual plan. So qual plans are very complicated, and there's a number of qual plans in DfRSoft. You should look at that video, and there's a semiconductor, hybrid, or assembly qual plans, and it's a full plan. We're going to look at accelerated test planning and still be combined, and we'll look at some of the results. So we'll be hyperlinking over to the test plan page. The first thing we'll do is look at some slides. So basically what we're doing is we're going to ask how reliable is our new design? Will it meet our reliability objective? And we may have a number of different kinds of tests that we want to do. And it may be a sophisticated test. You can look at sophisticated tests in qual planning. But nevertheless, in the accelerated test planning, we're answering the question, how reliable is our design? What is the statistical significance of the test? These are questions that our customer is going to ask of us. So this is really assuring the reliability for your customer. And it's not just engineering confidence that we did a good test. We want to know statistically what we're proving given the population and the test time that were tested, what we're actually achieving. So we want to understand the confidence around our failure rate, and we do this with the ChiSquared test planning calculators, and we estimate the sample size with ChiSquared test planning. Y is the number of failures, gamma is the confidence level, and this is the upper bound on our failure rate that we were looking at. So we'll discuss that in a minute, and our acceleration factor and test time. So let's go over to DfRSoft and see how DfRSoft makes that easy for you. The first calculator is for ChiSquared calculator for estimating the test time. And our goal here, let me zoom in on it. Our goal here is entered as we want to have an MTBF of say 1,000,000 hours, and that's equivalent to 1,000 fits. We're going to test 100 samples. We're going to allow for one failure. You want to allow for a failure once because you may get a failure on test, and you want to make sure that you've set up your test correctly with your device test time. And if you put 0 failures, you're going to reduce your test time, and you may not. You may end up with a failure and say, "Oh, I wish I had tested longer." And you put in your stress and use temperature and activation energy that's typically used from historical models, and the results from the calculator in hours right here, or you can do it in days, for example. You can switch between the two. There's 152 hours, and there's your acceleration factor. Then there's another calculator. This is a simpler calculator. We entered the same kind of parameters, and so here where each calculator on the right will answer the question on the top line. So if we put in test time, it'll tell us what our test time should be. So in this calculator, we've set it up for the same parameters here. In 100, we're looking at 1,000 fits. Our acceleration factor is 254 from down here. It says we need to test for 153 hours. And there's your sample size planning and your failure rate planning. Same kind of questions, different achieving. And now when we say we're achieving, say, 1,000 fits, what that means is with a chi-square that if we did this at the 90% level, that 9 times out of 10, our failure rate would be no worse. By repeating this test 9 times out of 10, our failure rate would be no higher than 1,000 fits. We would say the failure rate is somewhere between a lower number and 1,000 fits. Also is a device hour calculator, which is a very important calculator because let's say you have two different tests. I did a test last month at 100 degrees C. This month I did a test at 120 degrees C on a number of samples, different sample sizes. And if I want to combine those two, what are those two tests? What have I achieved between those two tests? Giving all things equal except different temperatures. Well, you can combine and add device hours for the two tests, and that'll tell you that the two tests for that many device hours is 1,000 fits. The next estimator is multiple chi-square testing. Typically in accelerated testing, the key test that we are doing is temperature cycle, temperature humidity bias, and H2O. For those three tests, we can combine and come up with what are we achieving for the total test in terms of our failure rate or MTBF. So basically you enter for each line, here's temperature cycle. We're doing the test duration is in cycles, and the pop-up tells you that. There's always pop-ups for help and everywhere. So if you have any questions. And you put in the use conditions, 30-degree temperature swing, and the pop-up tells you you're doing delta T. And your stress conditions, 205, so you might be going from minus 55 to plus 150, 150 degrees C, and the delta swing would be 205, so we enter 205 there. And the Coffin-Manson exponent of 2.5 for solder joints might be used. Now for temperature humidity bias, the top line is THB is the humidity line. So all these parameters have to do with humidity, 40% relative humidity. The stress conditions is 85%, and our Coffin-Manson exponent of 2.66. Temperature, the next line down for temperature humidity bias, it has to do with temperature. So it's 1,000 hours is the whole test though, and these two numbers are your temperature swings as of 25 and 85 degrees C. And your 0.7 EV might be your historical activation energy. And over here is the results for each test. And it says I've done for temperature humidity bias acceleration factor 713. There's my accelerated hours, and here's my years that I've achieved for each test. We also include vibration, but it's not included for the combined failure rate of just those three tests. But it will give you the failure rate that you achieved for vibration alone. So now we're going down and we put in the confidence that we're going to do. Say we want to do it at the 90% confidence level, so we enter that, and we enter the sample sizes that we're going to do, and we enter the number of failures and the percent duty cycle that we anticipate in the field. And there's a pop-up that explains that. And it says that we're achieving for this combined test with those sample sizes and the number of failures that we're planning for, that we would achieve 303 fits. And also the MTTF is provided as well for each under this line right here in the totals. So the other calculator that's very important is over here for that same test. You may say, well, I don't want to figure out my sample sizes. I want the calculator to do it for me. I have an objective, and my objective is, say, 400 fits for all three tests of temperature cycle, temperature humidity bias, and H2L. And this is the number of failures. I'm going to do zero failure testing. So this gives you an optimization routine. It says for the test times I'm going to test, and for the failures I'm expecting, it gives me my optimum number of units that I have to test for in this column right here. So there's an optimization routine in DfRSoft. And the results for what I've achieved is down below here, and you can cut and paste that into a Microsoft Word or something like that, and it tells you what I've achieved for all three tests. Also, there's a graphical results for H2L by itself and all three tests combined over the temperature range that you entered. And so that pretty much concludes our 10-minute video that we have time for. If you have any questions, send them to DfRSoft@comcast.net. dfrsoft.net, or you can find us on our website, dfrsoft.com. So DfRSoft, making design for reliability very easy for you. Thank you.